What are you doing? Jesse's being weird. Everybody watching YouTube right now, Jesse is being weird. Okay, so let f be the function defined by this. Why is this automatically a confusing problem? No. Well, not because it has two variables. It has two constants. It has a here, which I don't know, and it has k here, which I don't know. Those are just numbers that we don't know yet that affect the graph. For example, a positive a is going to make x to the third look something like this. And a negative a would make it look something like this. But either way, it's going to just change it depending on what it is. And a lot of these questions, it's going to tell you different scenarios. So let's look. First time, or part A equals 1, k equals 3. If f is continuous, is f continuous? So just from yesterday, how do we find whether it's continuous?
If you could draw it without picking up.
Right, it would be awesome if we could just draw it without picking up the pencil or pen. But mathematically, how do we show whether or not? Right, so you're gonna check the limit from both sides to see if they go to the same thing. So the limit of what? Well, what point are we approaching?
Approaching 1 from the left side.
So not approaching 1, approaching 2, because this is where problems occur. Limit as x approaches 2, of which piece of the function are we looking at right now? The top one, which when you plug in a equals 1 and k equals 3, it's going to look like x to the third minus 4x plus 1. So this type of problem doesn't really need limits. You can go ahead and just plug in. So this is going to become 2 cubed minus 4 times 2 plus 1, which is, what's 2 cubed? Minus 8 plus 1. So cancel, cancel. 1. So from the left, oh, I'm sorry, I didn't write from the left. The limit goes to 1. From the right, k is 3, so I'm going to write 3 square root of x minus 1. From the right, plug in 2. What's the cube root of 1? Also 1. So the limits from both sides go to 1. Is that enough to say that it's continuous?
Same slope.
No, nothing about differentiable right yet. That's not quite enough. We're just saying that the limit from the left and the right equal.
They're approaching the same point.
So what these two things say is that the limit of f of x as x approaches 2 from both sides is equal to 1. That's all we just are, that's what all of this is justifying. What we're also going to do, what we also need to do is to show that f of 2, the actual value, is equal to 1. Hopefully it is. The thing is, f of 2 looks a lot like just plugging it in, like we've already done. We just have to show that we are plugging in f of 2. So what is f of 2? Which piece does that go into? It goes into here. Which is the same thing. Oh, I'm sorry. What happened here? I made a mistake.
It's not 3 cubed. It's 3 times.
See here, I went 3 times this. Do you guys see where I made the mistake?
No. Oh. Oh.
This was k. K times square root. Then I accidentally made it a cube root. So I'm gonna do this.
You're gonna confuse your viewers.
It's only us though.
So this part's messed up. Here I'm gonna get 3 times this, which is gonna be equal to 3 times square root of 2 minus 1. Square root of 2 minus 1 is
3 times square root of 1.
which is just 3. So notice this and this do not equal, so that means this was wrong.
Just erase it.
What we can say, oh I'm sorry, here, I'll do this. Not necessarily wrong, what we can write is that this equals, it's not equal to 1. When the two limits don't match up, what do we write? That limit does not exist. So that means that this is not continuous.
Mister, why did you do
So I didn't even need to do this. I started to because we would have done that on the next step. Any questions? What about this next one? If I want it to be differentiable, what do we need to look at? Look at the continuity. Is it? So first I need to make A and K such that it's continuous. So one, I need to find A and K that makes it continuous. And then I need to find it so that they are also differentiable. So the derivatives are equal. So what do we need to do?
The slope.
So they need to be, the two pieces of the function need to be equal. First, just do continuous. They need to be equal at x equals 2. What? So let's do this. Do you guys have any idea what to do?
Don't you set it up equal to 2?
We don't want it to equal to. We know x equals 2. But what do we want to do? Okay, if we're showing, we want to show that it's continuous first. What do we need to do?
Both of them are the same at 2.
They need to be the same at x equals 2. So we need to set them equal to each other and plug in 2. So Jocelyn, what do you think we need to do now?
Can I draw it? So we still use 1
Jocelyn.
and 3?
Is it the same thing we did on top?
Just about. We want to see if they equal each other, but this time we don't just see if they're equal, we make them equal.
So we put them equal to each other.
We want ax to the third minus 4x plus 1. We want that to be equal to k square root of x minus 1. Okay, does that make sense? We want the pieces of the function to equal each other. We also know, but where do we want them to equal each other?
At 2.
At x equals 2. So x equals 2, it's going to look like this. A 2 cubed minus 4, 2 plus 1. And what's the other side going to look like?
K
2 minus 1. 2 cubed is 8. A minus 8 plus 1. What's square root of 2 minus 1? Square root of 1, which is just 1. So I'm just going to have k here.
What is K?
So the only thing I can do right now is simplify this just a little bit more. I can write 8a. So what's the problem here? I have 2 variables. So I can't solve for 1 because I'm just going to get another variable. So, well, what we're doing is we're setting this up. This condition needs to hold. What we're going to do is look at differentiability, set those equal to each other, the derivatives, and then something will make itself obvious. So right now, this was working with whether or not it's continuous. We're going to now look at differentiability. So what do I need to show, or what needs to be equal to each other? The slopes. So what would the slopes be if I take the derivative of each one of these? So let's look over here. What's the derivative of this? 3a x to the second.
Minus 4.
And I want that equal to, what's the derivative of this? Well, here I'm going to write this. Okay, so I need to do a little bit of side work.
Move the half to half K times negative 1.
Just leave it like this because the inside function, the derivative is 1. So the chain rule is, you could use the chain rule, but it doesn't change anything. Okay? So I want that. Now, what can I do now?
What? Divide the slope?
Well, I want the slopes to equal, but where?
At 2.
At 2, so I can plug in